So we're moving into multiplying or dividing rational expressions. And we're still going to follow the FFCC rule. And of course, when we're multiplying, we just multiply straight across. And in the end, there is no need to multiply the remaining factors together. Just leave it factored. And I say that, which leads to the caution sign here. You determine the domain before any factors are canceled. That's critical. So in this particular example we've got first, we're going to factor everything first. So let's go straight into factoring. And in this particular problem, I am going to work to the right here. So x squared plus 5x plus 6, that is x plus 2 times x plus 3. Why? Because factors of 6 that add up to 5 are 2 and 3. Over x squared plus x minus 6, that's going to be x plus 3 times x minus 2. Why? Because factors of negative 6 that add up to positive 1 are a positive 3 and a negative 2. Keep going. X squared plus 9, that's the DOTS. X plus 3, x minus 3 conjugates. And then x squared minus x minus 6, very similar to the other denominator, but this has a negative sign in the middle, so that means that the 3 will be negative and the 2 will be positive. Stop. Caution right here. Before anything gets canceled, we need to look at the denominators. So here's a denominator and here's a denominator. Look at both of them and ask what's going to be restricted from the domain. So our domain restrictions, x cannot equal negative 3, positive 2, positive 3, and negative 2. So those are our 4 domain restricted values. Okay, now that we have factored, now that we have determined the domain, now we can go cancel crazy. So we have an x plus 3 cancels with an x plus 3. An x minus 3 cancels with an x minus 3. An x plus 2 cancels with an x plus 2. We are left with x plus 3 over x minus 2 as the simplified result with the restricted domain values. Let's keep going. Dividing. Remember, division is simply multiplication by the reciprocal. Multiplication by the reciprocal. We're still going to FFCC, but caution up again. And this time I've got a question to consider. How is determining the domain different when dividing? So let me go back to my handy dandy notepad here. And I'm going to rewrite this problem because we've got our old pal, the division sign here, but what if I wrote this fraction divided by a fraction as a complex fraction? Which we're going to see that again soon, different notation, but take a look at it now as a little intro into our last section. Over x squared minus 9 divided by x minus 4 times x plus 3. So think about this division problem as a big fat fraction. And if we think about it as a big fat fraction, look at all the denominators. This is a denominator. And this whole thing is a denominator. The only part of the complex fraction that's not a denominator is the very tippy top expression. Which means Whatever will make this equal to 0 must be excluded from the domain. Whatever will make this equal to 0 must be excluded from the domain. Whatever will make this equal to 0 must be excluded from the domain. So in this big fat fraction, 1, 2, 3, 4, 4 factors to consider. Now x plus 3 is a factor of that, so it'll be repetitive, but our domain restrictions for this particular problem will be x squared minus 9 equals 0, so that means x cannot be plus or minus 3. X cannot be 4, and of course this is negative 3 again. So our domain restrictions, 1, 2, 3 values representing these 3 distinct expressions. So big fat fraction. That is how determining the domain is different when we're dividing. We have to consider everything that could be in the spot of the denominator. Okay, so let's take a close look at this problem. First thing I'm going to do is ditch division, because division really doesn't exist. Division is just multiplication by the reciprocal. So this whole thing is going to turn into x squared minus 2x minus 8 over x squared minus 9 times x plus 3 over x minus 4. Multiplication by the reciprocal. But once again, the domain is always relative to the original given problem. So now we need to apply FFCC. So we're going to go have a factoring frenzy before we go cancel crazy. I'll work down the page here. Factors of negative 8 that add up to negative 2, that's x minus 4 times x plus 2. Factors of x squared minus 9, x plus 3 times x minus 3. And then this little guy is already factored, and this little guy is already factored. Now these are not in parentheses, but we can put them there. No big whoop. So cancel, 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 cancel. There's what we've got. Our simplified answer is x plus 2 over x minus 3, with x not equal to our domain restrictions, plus or minus 3 and 4. Be prepared in your online homework to give domain restrictions as well as a simplified factored answer. Last problem. Happy little division problem here. And let's go ahead and, this time let's factor first. We'll factor first. So this is going to be x minus 5, x plus 5 to the bottom 2 times 1 minus x. All that's coming out, here's a GCF. X squared plus 10x plus 25 is going to be x plus 5 squared. And x squared plus 4x minus 5, factors of negative 5 that add up to 4, that's x plus 5 times x minus 1. Now, before we go anywhere, think about the domain restrictions. We've got to consider this expression, this one, and this one. So our domain restricted values, x cannot equal a 1, a negative 5, a negative 5, and a 1. Looks like we've got them. Don't even need that last comma there. Those are our domain restrictions. So now let's change this division to be multiplication by the reciprocal. So x minus 5 times x plus 5, I'm just recopying these factors, over 2 times 1 minus x times x plus 5 over x minus 1 over x plus 5 squared. Now that we have factored everything, we have changed the division to be multiplication by the reciprocal, now it's time to go cancel crazy. So what's going to cancel here? Well, x plus 5 times x plus 5 is the same as x plus 5 squared. So all of that is canceling. Now, I chose this problem so we could very carefully consider these two factors. Are they related? Yes. Yes, they are. Let's take a better look at what happens if we have x minus 1 over 1 minus x. Now they have a special name, and before we cancel them, how about we do a little substitution here? Let x equal 5. If we let x equal 5, what do we get? We get 5 minus 1 over 1 minus 5, which is 4 over negative 4, which is negative 1. Yes, indeed, ladies and gentlemen, these two expressions are opposites. So, they're both subtraction, they just have an inverted order. So they're not the same because subtraction does not have the commutative property, but they are indeed opposites. I'll extend my little note box. You can also see that they're opposites because look at what happens if I add them together. If I add them and if I add opposites, I should get 0. Do I? Yes. X plus negative x, 0. Negative 1 plus positive 1, 0. So yes, they're opposites. They are indeed opposites. So when I cancel 1 minus x with x minus 1, a negative 1 is going to pop out. So we can write this answer a couple of different ways. We can say x minus 5 times negative 1 over 2. Or we could shift the negative to the bottom and just say x minus 5 over negative 2. Both of those answers are correct, and those are your domain restricted values.